Question 2 on the physics test on College Board's website is: which graph best represents the magnetic field measured at the center of a coil due to a steady current as a function of time? Now, I'm going to try to show this on just one loop because the principle is the same for the coil. So the current, the steady current, is flowing this way through the coil and out this way. So the magnetic field, we can find the magnetic field with the right-hand rule. So if the current is, if my thumb shows the direction of the current, then my fingers will show the direction of the magnetic field. So in this point here, my thumb goes this way, and my fingers go around it and through the center in this direction. So the magnetic field is in this direction. Now, if I'm looking from this point on the loop, it's going to do the same thing. So my fingers are going this way, and the magnetic field is going again in this direction. And from this point of the loop, again, so my thumb shows in the direction of the current, and my fingers, this looks a little bit hard. It's a bit harder to do, but my fingers are pointing again in that direction. So again, the magnetic field points in this direction. So we know the equation for the magnetic field in the center of the loop. It's B equals mu naught times the current divided by 2R, where this is the steady current. This is mu naught. This is just a constant. It's just a number. 2 is also just a number. And R is the radius of the loop. Now, when we have a coil, this simply becomes B is equal to mu naught times the steady current over 2R, but times N. And N is the number of turns the coil has. So, in our case, where we have a steady current, our graph is going to be simply a constant, because the magnetic field is directly proportional to the steady current. Now, since the current doesn't change, the magnetic field doesn't change. So time and magnetic field, it's simply a constant. And that is the answer C.